first thing we need to do here is to write f of z in partial fraction. So of course we know that 1 over z, so 1 to retrograde z,
Okay, so I've gotten to the partial fractions. I'm just at the f of z,
so
which is when I substituted
I
the
know
partial
that
fraction with one
so
more.
first we express this in terms of partial fraction. So without wasting time, you need to do the partial fraction of this.
Okay.
Obtain a to be 1 over 8, or b to be negative 1 over 8, c to be negative 1 over 4, and d to be equal to um, d to be equal to 1 over 2, negative 1 over 2.
1/2, negative
So that
1/2.
we have 1 over z plus 2 raised to power of 3 to be equal to 1 over 8z plus uh, minus actually 1 over 8 z plus 2 minus 1 over 4 z plus 2 all square minus 1 over 2 z plus 2 raised to power of 3. Of course, this is f of z, right? So that means f of z is equal to
Yeah.
1 over 8z minus 1 over 8 z plus 2 minus 1 over 4 z plus 2 all square minus 1 over 2 z plus 2 raised to power of 3. So basically what will happen from here is
Mm-hmm.
that we need to write 1 over z plus 2 in terms of power series, and in fact that is what we want to do. That's what is called Laurent series.
Mm-hmm.
The same thing with 1 over z plus 2 all square, as well as 1 over z plus 2 all raised to the power of 3. Now I start with this. Um, now let's say 1 over z plus 2, for example. Now there is something you need to understand in this place before I continue. Uh, remember sum to infinity. When you have a GP, a geometric progression, let's say 1 plus x squared plus s cubed plus s raised to power 4, and it goes to infinity like this. If you are to compute this sum, say s, find s. This is a geometric progression with the first term 1 and the common ratio to be x. Because if you look at the first term is just the first number, that is 1. The common ratio is the second term divided by the first term, that x divide 1 is x, or
Mm-hmm.
x squared divide x, the answer is x. That's common ratio. So in reality, in GP, the sum to infinity is always given as a over 1 minus r. Although the condition for this to happen is that r has to be, the absolute value of r should be less than 1. But then let's solve this.
Mm-hmm.
I have 1 over 1 minus x. So that means the summation of this series, 1 plus x squared plus x cubed plus x4, like that, the answer is 1 all over 1 minus x. So that is the concept I'm going to use here. So basically what this means is that when you are 1 all over 1 minus x and you want to write this in series form, this is exactly 1 plus x squared plus x cubed plus x4, and it goes on like that. So coming to this, I will factorize 2 out. Basically, I want to get this format. I want to get this format here, 1 over 1 minus x. So factorize 2 in this case so that this will become z over 2. Maybe I should write it this way now, plus 1. If I open the bracket, I have not changed anything. So this is equal to 1 over 2 multiplying 1 over 1 plus 1, z over 2 rather. So this is exactly 1 over 2 multiplying 1 divide 1 minus multiplying minus z over 2. So this is my x. This is my
Wait,
x.
how did you get one minus? How did you get the? Oh, so you're just trying to make it to be that one.
Yes, I try to make it this way. 1 over 1 minus x. So this is 1 over 1 minus x. So my
Mm-hmm.
x here is minus z over 2. So what does that mean? This means 1 over z plus 2 is equal to 1 over 2 multiplying 1 over 1 minus z over 2 will be equal to 1. So if I want to write in series form according to this, this will become 1 plus x, but then my x is minus z over 2 plus minus z over 2 all square plus minus z over 2 raised to the power 3. So I do not forget this 1 over 2. I'm just writing. Basically, I'm just evaluating this.
Mm-hmm. No, I see it. Yeah.
So now I have a plus minus z over 2 raised to the power 4, and it goes on like that. So I can write this using summation. If I want to write this using summation, I say summation from n starting from 0 to infinity of minus z over 2 raised to power n. So I can leave my answer this way, um, whichever one is fine, or I write completely. Now I'm done with that first case.
So, question. Sorry. So basically, to get the sum of one over one minus x is always going to be the summation from n equals 0 up until infinity of x to the power of n or minus x.
Exactly the point, x raised to power n.
But is it going to be n or minus? I mean, it's going to be minus x or
It's an
x. Excuse me?
x, x. Basically, if you let with look at this place, if you let x to be equal to minus z over 2, for example,
Yeah,
this will become 1 over 1 minus z over 2. My point is that
yeah.
dx I replace with minus z over 2. This is summation.
Okay, I see it. I see it. And because it's a minus in front, you have to put in the minus in there. But if it was a minus x, it's just going to be positive x to the power of n, right?
Yeah,
Okay. 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 So that's the first one. And
yeah.
then the second
The second one I have so basically I'm done with this. The second one, um, I have 1 over z plus 2 raised to power 2. So basically, I just leave the coefficients for now. I will include them
one.
at the final answer. Do you understand my point?
But then you didn't do z.
What do I mean by I didn't do Z?
You didn't do z like 1/8 z.
Oh, 1 over 8 Z.
Yeah, is that a silly question?
So basically, okay, let me go back to to- so basically, look at what I'm doing. Oh, 1 over 8 Z. Yes, I don't do that because it's just 1 over 8 Z. Just Z.
Oh,
Like
okay.
1 over Z. You
Okay.
understand?
Yeah, I do. Yeah. So we have z plus 2 to the power of -2.
Yes, exactly. So this will become Z plus 2 raised to the power of minus 2. Do you understand my point?
Yeah.
Good. That was the first thing to know. But now we use another concept. to evaluate this. Now, what is
Mm-hmm.
this concept going to, how is this concept going to be? We'll come to binomial expansion. Look, I'm going to give you the formula. Actually, I can just write the answer right away, but then I need to show you how to get my point. So look at this. I have, if you have something like this, 1 plus z raised to power n, and you want to expand this, this is 1 plus n z plus n minus 1 z over 2 factorial z squared. Have you seen this before? N
Mm-hmm.
minus 1 n minus 2 over 3 factorial. But then it should be z raised to power 3. Get my point. Z raised to power 3. And it goes on like that, right?
Yeah.
Good. That's what I'm going to do here. I'll try to write this in this form. How?
Did you put n minus 2 there? So n times n minus 1 times n minus 2 divided by 3 factorial, right?
Yes. Then z
Okay.
multiplied by z raised to power 3.
Yeah.
So this basically is equal to, look at this,
Okay.
2 plus z
Okay. So z plus 1.
right?
Um,
Do you understand this?
yeah. But wait, hold on. 2 divided by 2, z over 2. So 1 plus z over 2. 4 minus 2. Okay. So is equals to 2. 4 minus 2. And 1 plus
Do
x.
you know that whenever a number is outside the bracket, it's for everything in the bracket. So uh,
Yeah.
by the time I open the bracket,
I have a question.
okay,
Okay, can you see my screen? Okay. So let's say you've got the minus 2 at the 2 without the closed bracket, the open bracket, if that makes sense.
if I get your point, that means you're trying to say, assuming I have 2, 1 plus z over 2 raised to power minus 2 this way.
Yeah.
Yeah, so this minus 2 is only for this.
Okay. I knew that then. If that's no, because I just thought I just needed to make sure because you said that it's for all of them. But yeah, continue
You
as you were.
understand this?
Yeah.
So this is 1 over 4. So I have 1 plus z over 2 raised to power minus 2. So basically, you replace now. Um, how will I write it? Now, what we have here, replace z with z over 2,
Mm-hmm.
right?
And end with minus 2.
Very good. And
So minus 2 minus 1 is minus 3.
you
And
understand
then,
that. So that means I have
yeah.
1 plus, and that's minus 2 multiplied by z over 2, right?
Mm-hmm.
Plus n, that's minus 2. Minus 2 minus 1 will give me minus 3 over 2 factorial z squared, that's z over 2 all square, right?
Yeah.
Plus minus 2 minus 3 minus 4 all divide 3 factorial z minus 2 raised to power 3, and it goes on like that. Do you understand that?
Oh, yeah.
According to binomial.
So z divided by 2,
What?
right? It's z divided by 2 to the power of 3, right?
Yeah.
Okay.
So basically, this will give me 6 divided 2, then 3 square over 4. Okay, don't let me expand. Don't let me evaluate that way. Let me just have c over 2 all square, then plus 2. Oh, this will become minus, not plus. Minus 2 multiplied by 3 multiplied by 4 over
24
2
z
minus.
over 2 times 3
Are you
times
getting
1.
my point?
I am, yeah.
So at the end of the this is 1 over 4, open the bracket, 1 minus 2 multiplied by z over 2. So don't expand completely. So you see what we get here, isn't it? I have 1 over
4.
1 minus 2 z over 2 plus 3 z over 2 square minus 4 z over 2 cube. You need to observe the pattern here. You actually need to observe the pattern here. This is equal to 1 over 4. I want to write a summation from that is my point. Summation
Mm-hmm.
of n starting from 0 to infinity since goes on like that. Now, you need to notice the unit. I mean the sign. The sign is alternating. This is you get my point. Positive, negative, positive, negative, positive, negative, and it's go on like that. You understand?
Mm-hmm.
This is minus 1 raised to power n. Set to that.
Mm-hmm.
Look at the coefficient. This is coefficient. Yeah, it's 1, 2, 3, 4, and we actually go on like that 5, 6, 7, and on like that. So the coefficient, since I'm starting from 0 and the first term here is 1, I will need to write n plus 1, then z over 2 raised to power n. That is obvious. Do you understand how I obtain this summation? A minute.
Yeah, hold on. Okay, so I get why you've done -1 because for the odd integers, it's going to be negative.
Yes.
So if it's odd, if it's cubed, it's going to be
But
negative, which is true,
negative for the even terms, positive.
and it'll be positive. Okay, so n plus 1 is because of the numbers in front. So 1, 2, 3. So n plus 1. And then z. Oh, I get it. Yeah, I get it. That is so smart. Hold on. So I see that you just so you kind of took 2 out to make it a binomial expansion. So it's going to be 2 to the power of -3 times z
Isn't
over 2
the
plus
same way we
1.
evaluated the first one? The
Yeah, yeah.
do you get
So
that?
then, yeah, yeah, yeah.
So let me just try to write that again here. So I
Okay.
have 1 plus z raised to power n to be equal to 1 plus nz plus n minus 1 over 2 factorial z square plus n minus 1 n minus 2 over 3 factorial z cube. You get my point?
Mm-hmm.
And it goes on like that. So in this case, of course, we replace z with z over 2 and n is negative 3. So this is 1 over 8. This is equal to 1 over 8. 1 plus n is minus 3, z over 2 plus n minus 3, n minus 1 minus 4, over 2 factorial z divided by 2 all square plus minus 3 minus 4 minus 5 divided by 3 factorial z minus 2 raised to power 3. Do you get that?
Mm-hmm.
Plus, let me write another one. Minus 3 minus 4 minus 5 minus 6 divide 4 factorial z over 2 raised to power 4, and it goes on like that. Do you understand?
Mm-hmm.
Good. Now this is equal to 1 over 8 1 minus 3 z over 2, right?
Yeah. 1 minus 3z over 2.
Yes.
Mm-hmm.
So plus
Well,
3
minus
times 4 will give
6.
me 12, isn't it?
Yeah, but then divided by 2 factorial.
And divided by 2. So this is 3 times 4 divided by 2. Um, z minus 2 all square, right?
Oh, why are you doing it like that for? Why don't you just um reduce it as you're going?
Because I want you to see a pattern.
Fine.
Actually, this one too. Okay, you will see the pattern yourself. Like, look at the next one. This will give me minus, isn't it?
Mm-hmm.
3 times 4 times 5 divide 3 times 2. Then 3 factorial is 6, 3 times 2, right?
Yeah.
Z over 2 raised to power 3.
Mm-hmm.
Then the next one will be a plus. This will give me 3 times 4 times 5 times 6 divided by 4 times 3 times 2. Then I have z minus 2 raised to power 4, and it goes on like that. So again, you will notice that 4 cancel 4, 3 cancel 3. Now what do you notice? Basically, I will write this in summation form. Obviously, n starting from 0 to infinity of of course, you will see that the sign is alternating, plus
Mm-hmm.
minus plus minus. So to settle that, you have minus 1 raised to power n. Now for the coefficient, listen, look at the coefficient here. Notice that you have 5 times 6 divide 2, 4 times 5 divide 2, 3 times 4 divide 2. In fact, this 3 that you have here is, I can write it as 2 times 3 divide 2. Do you understand?
Mm-hmm.
Even this one that you have here, I mean, I'm just talking about the coefficients. This is exactly 1 times 2 divide 2. So basically, the coefficient is for k plus, I'm using n, not k. I have n plus 1 multiplying n plus 2. Since my n is starting from 0, and I have 1 multiplied by 2, so I have to do n plus 1, because if you put n to be 0 here, 0 plus 1 is 1, 0 plus 2 is 2. So n plus 1, then n plus 2 divide 2. That will be the coefficient. If you go to the next term, put n to be 1, for example. 1 plus 1 is 2, 1 plus 2 is 3. That is 2 times 3 divided 2. If we go to the next one, 2 plus 1, 3, 2 plus 2, 4. That's 3 times 4 divided 2. Do you understand my point?
Mm-hmm.
Z over 2 raised to power n. So this is writing in summation form.
Mm-hmm.
Do you get that?
Mm-hmm.
Now that we have written all this, you just recall that f of z that we have written in partial fraction, maybe I should write in black ink, is equal to 1 over 8 z, right? Minus 1 over 8 z plus 2 minus 1 over 4 z plus 2 all square minus 1 over 2 z plus 2 raised to power 3. Do you understand that?
Mm-hmm.
So we have 1 over 8z minus 1 over 8 z plus 2. 1 over z plus 2, we've done that before. 1 over z plus 2, we've done that before.
Yeah, we had
What was the answer we obtained when we did 1 over z plus 2?
we got the summation of negative z divided by two.
Yes, 1 over
Oh,
2 summation of n starting from 0 to infinity of
yeah,
minus z over 2 raised to power n. This is multiplying 1 over 2, isn't it? From n starting from 0, right, to what? Infinity of
mhm.
minus z over 2 raised to power n. Now I come to minus 1 over 4. 1 all over z plus 2 square will be what?
1/4, the summation from n
Yeah,
equals 0 to
1 over
infinity
4.
of
Summation of
minus
n
1.
starting from 0 to infinity of minus 1 raised to power n, right?
Yeah,
We have
times
n
n
plus
1 times
z
z
over 2
to the power
raised
of
to
n.
power what? N,
And
right?
yeah,
Good, that's all. Now the last one, minus 1 over 2, 1 over z plus 2 raised to power 3. We got 1 over 8 summation of n starting from 0 to infinity. Can you hear me? Of
I am, yeah.
minus 1 raised to power n. Then I have n plus 1, n plus 2, divide 2 z over 2 raised to power n. Do you understand?
Mm-hmm.
And we are almost done with this. This is minus 1 over 16 summation of n starting from 0 to infinity of minus z over 2 raised to power n. This is also minus 1 over 16. Now, basically, if you look at this, minus 1 over n, 1 minus 1 raised to power n and z over 2 raised to power n have the same power. I will still use the same thing for this case as well. So my point is I have minus 1 over 16 summation of n starting from 0 to infinity of n plus 1 raised to power of minus z over 2 raised to power n minus 1 over 16 summation of n starting from 0 to infinity of n plus 1 n plus 2 divided by 2 minus z over 2 raised to power n. Do you understand that?
Yeah.
So f of z,
But you're going really fast.
oh, I'm too fast.
A little bit, yeah.
I have minus 1 raised to power n multiplying z over 2 raised to power n. You get that?
Yeah.
So they both have power of n. I can say minus 1 multiplied by z over 2, everything raised to power n. It's still the same thing actually. So this is minus z over 2 raised to power n.
Let's just see if we can small eight.
At the front of each summation, minus 1 over 16 is present. So I factorize minus 1 over 16.
Um,
so that I have
Yeah.
function of n starting from 0 to infinity. Then also you will notice that minus 0 over 2 is common throughout the summation. If I factorize that, I'll be left with 1 plus n plus 1 plus n plus 1 n plus 2 over 2 factorial or over 2
Oh, you're going too far.
minus 3
You're
over
going fast. You're going too fast. You're going too fast. Is equals to 1 over 8. Please, can I just get to where you are? Is that it?
yes,
Hello? That's it?
yes.
You're so smart. That, amazing. Mwah. Question. You put a boundary, you said, such that.
Now such that um absolute value of g over 2 is less than 1. So this is there to show when the series will converge. Can you hear me?
Yes, I can hear you. Say that again.
If you remember the sum to infinity I said earlier, a over 1 minus r, right?
Yeah.
Possible when the absolute value of r is less than 1. Do you get that?
Yeah.
So that's exactly what we use in this example, or in this case. If you look at when I was using that summation um, for this z plus 2, my r was z minus z over 2. Do you understand? But since it's inside the absolute value, I don't need to put minus again. Do you understand? The series will converge if summation of minus z, the absolute value of minus z over 2 is less than 1. And summation of absolute, I don't know why I'm calling summation, but absolute value of minus z over 2 is same as absolute value of z over 2 and it's less than 1. So the series will
Okay.
be valid or it will converge when absolute value of z minus 2 is less than 1. Do you understand?
Mm-hmm. I do, yeah.
And this is the required Laurent series we want to obtain. Good.